Probably right after school.
I'm back.
All right, got you. Yeah, I'll probably be here. All right, thank you.
All right, here we go.
If you were to bring me that sauce, I would complain now.
I'm probably gonna like
All right, we have two different titrations that we're going to look at. The first is going to be a strong acid base titration. And the second is going to be a weak acid strong base titration. Okay? In this first one, we're going to use nitric acid. In the second one, we're going to use acetic acid. Okay? In the first beaker, we have 25 milliliters of 1 molar HNO3. In the second beaker, we have 25 milliliters of 1 molar acetic acid. Okay. First question I'd like to ask you, what is the pH at equivalence for each? This one? This one? Oh, this is a weak acid. How do I figure out what the pH is going to be for this one? What do I know? Moles of the acid has to equal moles of the base. How many moles of acid do I currently have in this beaker? That's my current concentration. How much of it do I have? So that's my moles of acid. If I know that that's going to equal my moles of base, which we have not talked about the moles of base yet, but the solution is being titrated, both of them. With that much NaOH. What's next? We need to know the total volume of the solution. That's the next thing, in case we're wondering. How do we figure out the total volume of the solution? We know how many moles of acid there are, which means we also know how many moles of base there are, correct? At equivalence? Okay. So if there are this many moles of NaOH, and I know I started with 0.1 molar NaOH, can I get a volume from those two pieces of information? Yes, I can. What do I need to do? I need to divide. I need to figure out what volume of NaOH is actually going to be needed to get to equivalence. Once I have that volume, I can get the molarity of the acid at the equivalence point, which means I can then do a pH. What we get? 0.25 liters. So it took 250 milliliters to titrate this thing to equivalence, is what that means. It's a lot, but that's absolutely correct. All right, so now my total volume is what?
275 milliliters.
.027 or 0.275, you're right. Sorry. Where is this? Anywhere wrong. What's the concentration of the acid then? Do I have moles? Do I have volume? You did this in lab, guys. You did this exact calculation in lab to figure out what the pH at equivalence was. Yep. What did we get? Molar. What do I do to that? Find the pH. Huh? 0.0909. Repeating. How do I get a pH? Take the negative log. What'd you get? Whew, that's low. That can't be right. 1.04? Hmm? It's still wrong. pH equivalent should be like 7.5. It's fine. We're gonna do something different. Yeah. I think I did volumes wrong. Huh? I just won't ask you to do that reaction.
Okay.
What can I ask you to do with pHs, I guess? With titrations. What have we done in class with titrations? Let's go with that. We did. We did a titration. What else what can I ask you to do with it though?
That's a really good question. That is an excellent question, Michelle.
I was close. I think I know where I went wrong, but I'm not going to ask you to find that. I would ask you just to know that it would be greater than 7. Because I don't really want to go through it again. I don't want to find my mistake is my problem.
So what we just did, we're not going to have to do?
You won't have to find a pH at equivalence for a weak acid-base titration, no. But what can I ask you to do with titrations that we did in class? Can't we find pHs along the curve? Isn't that what we did? Where we said, what is the pH when we add 25 milliliters of this? Or what is the pH when we add 30 milliliters of this? No, we were looking for a pH at equivalence. That was different. Yeah?
Should we erase everything we just did then?
Yeah. Please do.
Yeah.
Yeah. All right, so question. Do we want to start with a titration that is strong or a titration that is weak? Because we're going to work on the actual titration now.
Strong first.
You want to do the strong one?
Yeah.
The strong one was the easier, right? It only had a few steps.
Mm-hmm.
What do we assume about strong acid-base titrations?
Carried out to completion.
Completion.
Miss Chef, you know I don't have that much room, too.
I don't know what to tell. Get a new notebook. Everyone complaining about how much space they have left in the room. Get another notebook. It's only March. I am not even close to done in this class. All right. So here is my curve, correct? If we know that this is volume, what goes on this side? Thank you. You should know. All right. Oh, you're fine. All right. Strong acid-base titration says equivalence is going to be 7. That's going to put us here. How do we find pHs before and after that?
Just change the concentration.
Right. So one of the things we're going to start with is that we know what the strength of the base is. Correct? I am going to change the strength of this so that we're not dealing with volumes that are like 300 milliliters. I'm going to make this 0.10 molar. So I'm going to move my concentration just a little. I will do that for this one when we get there. So I'm just changing up the original information a little bit so that we can get volumes that are more sensible. Okay? We're still going to start with 25 milliliters in our flask of the 0.1 molar strong acid. Yes, ma'am? Yes. Next thing that we're going to do is we're going to try to determine what the pH is as we add different amounts of the strong base. Now, the strong acid-base reaction, what is it? Always. Okay? H plus plus OH minus makes water. This is the strong acid-base reaction, not this one. Ignore this. Okay. So let's do this at 4 points, 2 before, 2 after. Okay? The first one we're going to do is 15 milliliters. Second one we're going to do is 20 milliliters. The third one is going to be 30. And the fourth one is going to be 35. These values are going to be volumes of the thing we're actually adding. So these are all going to be 0.1 molar NaOH. When we do titrations, what goes in the table? We always do the ice, right? But in this particular type of reaction, are we putting molarities in there or are we putting moles? We do moles with titrations to save ourselves a step. Okay? All right, in part A, 15 milliliters of 0.10 molar NaOH gives us how many moles of NaOH? How do you do that calculation?
0.0015.
So you're going to do 0.015 liters, because that's 15 milliliters in liters, divided by 1,000. We're going to multiply it by the 0.10 moles, which has a bottom unit of liters. What are you going to get?
0.0015.
Okay, so that's part A. I'm going to erase this just so you know. I want you to do the same thing for B, C, and D before we actually do the problem so that you have everything set up. For B, you're doing 20 milliliters of 0.01 or 0.1, which is going to be what? Okay? For C, what are you going to get?
0.002.
30 milliliters of 0.1 molar means 0.003 moles. Don't forget, these are all NaOH, and this is going to be our NaOH at 4 different points along our curve. We're going to have one here, we're going to have one here, we're going to have one here, we're going to have one there. Okay? For D,
0.003.
nice. Okay. What else do we need moles of? The acid, right? We're starting with 25 milliliters of 0.1 molar, so what's our moles?
0.0025.
Right? All right, we're set up. Now what? Where's this number go?
Initial.
That's this guy, right? This one's always going to be 0. We're going to assume that what we're adding is the change, right? So in part A, the amount we add goes here. Which one of these is going to get completely consumed? The OH, right? And in doing so, none will be left over. How much of this will be left over? Hold on, Adrian. Yeah. Right? this is a number in moles, don't forget. At this point in part A, what's our total volume?
0.01.
Nope. Total volume. How much have we added together? 15 and 25, right? So 40 milliliters. We know what our number of moles is. We know what our volume is. We can get a concentration from that information. Here we go. Say again?
0.025.
That's molar. What is that? H plus or OH?
H+.
That's H plus. How do we get a pH?
Negative log.
Take the negative log. What do you get? Be more specific. Should be small.
1.602.
Okay. So on the curve, where are we? We're still on this part, in part A. Who does this ring a bell? You did this before. You did this many times. You did this in two different big ways. Last week. To be specific, it was last week. All right. What's next? So that was A. Ooh, I'm going to change color. Our pH in A was 1.602. Oops. Okay. Now let's do B.
Why would you use the ML-NaOH to get the H plus in the bottom?
Oh, I didn't. No, I didn't. That's not.
No.
That's not. That was liters. I was calculating H plus, don't I? All right. For B, we have 0.002 moles of NaOH. Which one's going to get completely consumed? Sorry.
DOH.
This guy, right? So there's going to be none left. What's going to be left over here? .0005 what?
Moles.
Moles.
Are there only 2 zeros or 3?
3. What's our total volume for part B? We started with 25 of the acid. Then we added 20. So what are we at? 0.045. All right. So then the concentration, in this case of H plus, is going to be 0.005 over 0.045, which is what? It kind of looks like a 5.
Wouldn't it be 3 zeros for 05?
Yeah, didn't you see my 0?
Which decimal?
So somebody
Shut up.
Point
What'd you say?
I said somebody dropped it.
009.
I was like, ooh.
That's not, I got 0.01111.
Yeah, I got.
Yeah, that's what I got.
Sorry.
0.01
Look at the
repeating.
next problem.
What do we do next?
Take the negative one.
Wait, are you sure? Is it 2 zeros and a 1?
No, only 1 0.
Okay, what'd you get?
1.95.
Cool beans.
Okay, what's next? Now we switch, right?
Gonna get a C.
in part C, what happens? 0.003 moles of NaOH. Which one gets completely consumed?
The H plus.
The acid. Leaves behind none of the acid. Leaves behind how much of this? 3 zeros and a 5. What's our total volume in part C?
55 milliliters.
Is this the one where you got 0.009?
Also, it's 3 O's for the pound.
Zach, stop missing it. What's the answer?
0.009.
With some other numbers, I'm assuming? That's your molar. OH minus. So what's your POH this time?
2.04.
Subtract from 14. What do you get?
1.96.
All right, do the last one.
Wait, why would you solve for OH in that one?
So remember, principle of acid base, strong acid, strong base says they're going to completely consume each other. And one of them will always be left over if we're not at equivalence. In this case, we consumed the H plus and we had leftover OH laying around. And they equally consume each other, 1 to 1. So for instance, in this one, we had more base than we had acid originally. So we consumed the entire acid. You can only react to what you have, right?
Yeah.
And then you're going to have something left over. That's what that's about.
So then you do
Get
the
the
same,
last one, please.
you do the same procedure for D, right? Or
Yes.
to solve for OH.
As we did for C, correct. What'd you get? 12 something?
Yeah, you definitely could. No, you don't, wait, you don't have to do that.
You gotta find the pH.
What'd you get?
I don't know if this is right.
Is it 12 something?
Oh yeah, it's like 12.3. That's at least what I got. I'm not sure.
I saw 12.22.
Don't do that.
Don't forget to take the 14 minus, because what you're calculating is POH.
That's not.
Yes. For which one? The one we're just doing now? Okay. What was your total volume? It should be 25 plus 35. So it should be 0.06. Not 0.006.
Yeah, but both of them have 2 zeros. The initial for the I and the.
Oh, are you talking about the value left over?
Well, you did it.
So
Or are you talking about the volume?
my total volume is going to be.
35 plus 25.
Oh, I
16 milliliters.
I didn't.
It should be 0.06. Where'd you get your pH?
Oh, I was gonna ask you.
So it's just
So the ice tables are kind of weird in these types of situations. Really, they're just there to remind us that we have something we started with. Okay? Otherwise, you have to apply the idea that as much of this that you add will react with as much of this as you have.
Okay.
So if this number is bigger than this one, you're going to subtract the 2, and this one's going to be the one that's left over. If this one's bigger than this one, okay, you're going to do the opposite. You're going to subtract whatever is left, and you're going to have 0 of this left over. Does that make sense? And then
Yeah.
whichever one you have left over, you're going to take the negative log of the concentration after you convert it to molarity.
Right.
Don't just try to take the negative log of the number, it won't go well. You'll be off to a point. But do that, and then you're gonna get either POH or pH.
Okay.
Whichever one you have left over dictates the pH or pH
Okay.
situation.
Thank you.
So I got this number when I changed it.
Am I good?
Okay?
Yeah, I feel like I wasn't at the end of I'm not, but then
Well, compared to me, look at that, like pasty. Red, white.
I'm gonna forward this.
Oh,
to you.
Okay, and then you do 14
No,
minutes.
that's- yeah.
Oh, okay.
Wow.
Yeah, that's right. Stop it.
No.
No,
Ice table.
right, poor soul.
My mom is calling us. She called him.
You said 130. So there's your molarity. Now do the negative log, and you get POH. Okay, subtract from 14. Yep, you should get 12.22. Yeah. You have the right pH. Oh, that's because you because you know what it is. Okay. So these numbers are ones we calculated earlier. Okay, so the 0.0025 was the 25 milliliters of 0.1 molar acid. Okay, and then we converted it to moles, and we got the 0.0025. So that number stays the same every time because that's what was in the little beaker. 0.0025.
This never changed in an hour.
That number changed in each problem, right? Like in A it was one thing, in C it was something different, and then in D it's 0.0035. So your number's right on here. Okay? No. So here's what you have to remember with acid base, is that as much as it possibly can is going to react. So you're going to have this much, but you can only react the 0.0025, right? You can't react any more than that. So you're going to have leftover over here, because that's what you added here. So 0.0035 goes here. Yes, except this number was there. This number was this number. Because you can't react more than 0.0025, right?
They named her Jubilee though.
Do you see what I'm saying?
Oh. So they had a
You
little
are
celebration.
Was the total volume on it? So what was the total volume for this one?
0.00. If I did it.
No, we're talking about the dog.
0.006. All right.
The baby that died, the oldest.
That's probably where I had it
Is the
wrong.
number that's not necessarily.
Yeah.
Okay, so here.
This one.
0.0035 plus.
Only 19 and counting. God. It's kind of like, think about it. If I have 10 M&Ms in my candy dish, I can only eat
That's
this
where I went
10
wrong.
I can't eat any more.
I'm actually surprised.
But do you see what I'm saying? That means that once you consume that, there's no data on that.
What the end was so high at the end of
So do you remember how we said it's 25 and plus? That's the original volume. That's what
You
it's
know,
called.
and I'm sure for a lot of those.
So what's going to be left over after you do this reaction is whatever the difference is.
You know, think about that.
She's had like, and what's going to be left over is OH.
That would be
That goes on the top.
What goes on the top of the fraction.
Like I said, it is
Especially
like,
after
Right,
you
that's absolutely correct. See that? So now you're going to take that molarity, you're going to divide by the total volume. Your total volume is the 25 that was in the glass plus the 35 you just added, which is 60 milliliters, so 0.06. Then you're going to do moles over liters, and you're going to get your concentration.
Do you know what the pH is for D?
For B?
D.
D. 12.22. Sorry. 12.22. 0.0 is the only other type of titration was the weak acid strong base. What's the next step you have to do with the weak acid strong base? To calculate an H plus, you have to plug in your equilibrium concentrations into a Ka expression. Don't forget that. Yes. Those of you that would like more practice with problems that are going to be in your quiz tomorrow, please come see me after school.
It's really small. But I don't
Wait,
know
what's
where.
the extra step?
It goes 0.002 for H.
So that one becomes 0 and this one becomes 0.001. Right.
So then you divide 0.0.
0.06. 60 milliliters is 0.06 liters.
0.06?
Yes. That's where your values are.
I'm sorry. What was the extra thing that you did with the
Justin does all the laundry.
acid
Makes
strong base
all the
reaction?
food.
So the next step is, okay, so with weak acids, I'm gonna keep things. Oops, sorry.
Chef, I'm using some of your lotion.
You're fine. Whatever you like. Can you hand me the...
I like ginger.
Say again?
0.06.
It's 0.06. 30 milliliters or 35 milliliters plus 25 milliliters is 60 milliliters. Divide by 1,000 and that's 0.06.
Can we not do one?
Put an empty bottle in there.
It's gonna have a titration on your quiz, I guarantee it. All right, so in a weak acid-base titration, okay, the first equation you have to use is this one. Okay, this is the first equation. This is the one that gets the ice table. Okay, say you started with 4.5. Okay, say we add how much base do you want to add? Let's go with 3.5.
Yeah, sure.
Give me simple numbers, right? Okay, that we can't ignore in this kind of an acid-base reaction. We can't ignore this.
All right. Yeah.
Okay, so we get this. Okay, and this is before you hit the equivalence point. After the equivalence point, this number is bigger, and you use the exact same principle we were just using, where you subtract as much as you can, you get 0, that kind of thing. Okay. All right. This is going to get consumed, so this is 0. This is 3.5. All right. Next thing.
Well, when they subtract off, why is it 3.5 right there at the end?
This one?
No, the one
Oh.
at the bottom there. Okay, I was gonna.
Because I'm not paying attention to my math.
I was
Okay,
like, okay.
but you're with me so far.
Yeah, I got you.
Okay, so next thing is we're going to take the Ka equation and the Ka equation adds water and forms what?
It's going to form an H plus, and it's also going to form just that without the H at the end.
Okay, yeah.
That's this.
Also, now we know the value for that.
You guys got, like, it was 2 and 0.
And we just use the original concentration up there. Oh, we use that.
We use the equilibrium concentrations from one reaction to the next.
All right.
Okay? Then we plug it into Ka. Provided I gave you a Ka value, so let's say 1.8 times 10 to the negative third.
All right, so 1.8.
Pretend these are concentrations too.
Times 1 in this, so this is going to end up being divided by 3.5. So that brings us at 5.14
Okay.
times 10 to the negative
5.14.
2. 14 times 10 to the negative 4.
Okay. A lot of times the goal is the pH, right?
Yep.
5.14 times 10 to the negative 4.
Negative 4. I said it wrong.
That's okay. That's okay. All right. So this is a concentration. So what do we do next? pH.
So, honestly, it's just kind of self-explanatory from there. All right, thank you.
If you can get here, you're good. But you have to get through this using the principles that we
And it
talked
makes
about.
sense. It's just all about recalling what you have